Welcome to all students. In my third video lectures, we have to discuss different parameters of the unit cell such as nearest neighboring distance or atomic distance, what is the coordination number, what is the number of atoms per unit cell. Similarly, what is the atomic packing factor for different unit cell such as simple cubic structures, body centered cubic structures or face centered cubic structures. First, we have to discuss number of atoms per unit cell. What is the number of atoms per unit cell? It is the simplest or easiest definitions. That is, how many atoms will form to these unit cells, such as suppose simple cubic structures. These simple cubic structures, how many atoms will be formed? Similarly, BCC structures or FCC structures. There is a simple formula. See here, that is N is equal to Ni plus Nf divided by 2 plus Nc divided by 8. Where what is the Ni, Nf or Nc? Here Ni is the number of atoms in a unit cell, that is the number of body centered atoms, that is the how many atoms which is inside this unit cell. Nf means the number of face centered atoms, that means how many atoms which is situated on the faces of the unit cell. Nc, this is the number of corner atoms, means how many atoms which is situated on the corners of this unit cell. And to find out the coordination number, number of atoms per unit cell for a particular unit cell, that is simple cubic or body center cubic or face center cubic. In last video lectures, these things already discussed. Means suppose the simple cubic structures, how many atoms will be formed this simple cubic structure? There is only one atoms to form this simple cubic unit cells. Similarly, BCC or body center cubic structures, there is only two atoms to form these BCC unit cells or two lattice points to form a BCC unit cell. Similarly, face center cubic structures, there are four atoms or four lattice points to form this FCC unit cell. Next point, what is the coordination number? There is a simple definitions of coordination number. The number of nearest neighbors that an atom has in a unit cell is called as coordination number. Means suppose the closest atoms for these unit cells, means suppose the simple cubic structures, how many atoms to closest at single corner atoms. Is it right? Means the nearest neighboring atoms to shows the coordination number. In simple cubic structures, there are 6 coordination number, means 6 atoms to closest that corner atoms in a simple cubic structures. That's why the coordination number is 6. Similarly, the body centered cubic structures, 8 coordination number means 8 nearest atoms for a body centered atom. Means the body centered cubic structures, the nearest neighboring atoms is 8. Similarly, face centered cubic structures, there are 3 axes or 3 planes, x, y, y, z or z, x. This is the 3 axis, and each plane or 3 plane or each plane there are 4 atoms which is present in plane. Means xy plane there is 4 atoms, yz plane there is 4 atoms, and zx plane there is also 4 atoms. Then 4 plus 4 plus 4, that is the 12 atoms which is present in that FCC unit cell. That's why the face centered cubic structures, the coordination number is 12. Is it right? See, this is the coordination number. What is the nearest neighboring distance or atomic distance? The distance between the centers of the 2 nearest neighboring atoms is called nearest neighboring distance or nearest neighbor distance. See, in this diagram, this is the 2 atoms, and the center between these 2 atoms, this is the radius of this single atom, this is also radius of this single atom. Then the distance of 2 atoms is 2r. Is it right? Where r is the radius of the atoms. Similarly, atomic radius. The definition of this atomic radius is defined as the half of the distance between nearest neighbors in a crystalline solid without impurity. Means in pure solids there is the atoms present in a solid, and the distance between the center to nearest neighboring atoms is r. That is the atomic distance. Next, what is the atomic packing factor or fraction? It is a simple definition of this APF. It is a ratio of volume of atoms per unit cell to the total volume of unit cell. This is the atomic packing factor of a particular structures or particular unit cell. This is the simple formula for APF. Number of atoms in a unit cell, that is the how many atoms to form these unit cells into volume of each atoms divided by volume of unit cell. Means it is the ratio of volume of atoms per unit cell divided by total volume of the unit cell. This is the definitions. Or the atomic packing factor shows the occupied space or unoccupied space in a unit cells. It is also defined as, or another definition of this APF is the fraction of the space occupied by atoms in a unit cell is known as atomic packing factors. Means the atomic packing factors to shows the occupied or unoccupied or empty space represents in a particular unit cell, means simple cubic body center or DCC structures. And this APF shows particular values. Means the packing fractions gives us an idea about how closely atoms are packed together in a given crystal systems. Means a low value of atomic packing factor indicates loose packing of atoms and there is more unoccupied space. Is it right? Similarly, a higher value of atomic packing factor indicates that the atoms are very closely packed in a unit cell and there is only a small unoccupied space. The packing fractions for some cubic systems can be obtained for next step. See, for simple cubic structures, this is the simple cubic structures, and the distance between these atoms, 2 atoms, is E is equal to 2r. Or example for simple cubic structures is polonium. We have already discussed for number of atoms per unit cell in simple cubic structures is 1, means there are one lattice points to form this unit cell. Similarly, nearest neighboring distance is also 2r is equal to a. Coordination number is 6. Lattice constant is a. A is a lattice parameter, that is 2r. Atomic radius is r is equal to a by 2. And the atomic radius is a by 2. Next, to find out the radius, atomic radius of simple cubic structures, volume of one atoms is 4 by 3, and this is the formula, mathematical formula. 4 by 3, volume of one atom is 4 by 3 pi r cube, where r is the radius of atoms. Where radius of atoms is already r is equal to a by 2. Put this value here, then 4 by 3 pi in bracket a by 2 bracket cube. Then to solve this is equal to pi a cube divided by 6. This is the volume of single atoms which is present in a simple cubic structures. Similarly, to find out the volume of unit cell in a simple cubic structures, the lattice parameter of simple cubic structures is a is equal to b is equal to c, means all the sides are equal. That's why the volume of this unit cell is a cube. Then the volume of all the atoms in a unit cell means how many atoms to form these simple cubic structures. There is only one atoms to form this unit cell. That's why the volume of all the atoms in a unit cell is equal to number of atoms per unit cell into volume of a single atoms. Is it right? Means the number of atoms per unit cell is 1 and volume of a single atom is 4 by 3 pi r cube. Is it right? Then to find out the atomic packing factor, see, this is the simple formula: number of atoms per unit cell into volume of single atoms divided by volume of a unit cell. Number of atoms per unit cell means how many atoms to form this unit cell, and this is just 1 into volume of a single atom is pi r cube. Is it right? And volume of unit cell is a cube. Put these all the values in this formula. See, this is the number of atoms per unit cell is 1, volume of single atom is 4 by 3 pi r cube divided by volume of unit cell is a cube. And to solve these equations, then to find out the value is pi by 6. Is it right? A cube get cancelled and there is only pi by 6. Put the value of pi and to find out the result, that is the 0.52 or 52%. Means in simple cubic structures there is only 52% space are occupied and remaining space are unoccupied. Is it right? Let us see here the packing fractions gives us an idea about how closely atoms are packed together in a given crystal systems, means simple cubic crystal systems. In simple cubic crystal structures, the atomic packing factors is 0.52 or 52%. Space are occupied and remaining 48% space are unoccupied space in a unit cell. Is it right? So in simple cubic structures is loosely packed structures, means these structures is a loosely packed structures. This is the different parameters of simple cubic structures. Then next structures is a body centered cubic structures or BCC structures. Lithium, sodium, potassium, chromium. This is the material shows the BCC structures. This is the diagram for body centered cubic structures. 8 atoms are situated on 8 corners, and this is the single atoms which is present inside the unit cells. And these all the corner atoms touches to body centered atoms. See another diagram here. This is the corner atoms and this is the body centered atoms. These corner atoms touches to these body centered atoms. Is it right? Then to discuss the different parameters of these BCC structures, such as atomic radius, what is number of atoms per unit cells, and so on. See, first to discuss the number of atoms per unit cell in BCC structures, there is a simple formula, and these BCC unit cells to form only 2 atoms. Is it right? See, this is the n is equal to 2 atoms. Means 2 atoms to form these BCC unit cells. Next, the coordination number for BCC structures is 8. In body-centered cubic systems, the neighboring atoms are at corners and there is a 1 atom at the center of the cube. Means all the corner atoms touches to this body-centered atoms. And to find out the atomic radius of this unit cell, that is R is equal to AO by 2, or AO is equal to 2R. Is it right? See, this is the diagram. This AO, this A to O distance, and this is the 2R. Is it right? This distance is R and this is R. This is the 2R, means OA, this is the nearest neighboring distance is 2R. That's why here OA is equal to 2R. And now we consider in triangle ABC. Here is the ABC, and this is the A, this is B, and this is C. Means this triangle, is it right? ABC. In triangle ABC, by using Pythagoras theorem, that is the AC square is equal to AB square plus BC square. Using Pythagoras theorem for this triangle ABC, that is the AC square is equal to AB square plus BC square. Is it right? C, that is the AC square is equal to 2A square, or take a square root, that is AC is equal to root 2 into A. Next, to form the geometry of whole structures, that is these corner atoms or these diagonals. Is it right? This is the diagonal of this unit cell. Then see here in this diagram, then the distance between this diagonal is 4R. That is the AD. Where is the AD? AD, this is the this diagonal distance A to D, and this distance is 4R. Is it right? This 4R. Consider the triangle ACD. Where is the ACD? In this triangle. See in this diagram, A, C, or D, means A, C, or this D. Means in this triangle, by using again Pythagoras theorem and to solve, next, that is AD square is equal to AC square plus CD square. What is the value of AC square? AC square is 2A square. Is it right? AC square is 2A square. And what is the value of CD square? Here CD means the distance, corner, the distance, this is A, bro, because this is the cubic unit cell, that's why all the sides are equal, that is A or A. and CD is A. Put this value, what is the value of AD? AD is 4R square is equal to, what is the value of AC square? AC square is root 2 into A square plus A square, is it right? Then 4R square, that is 16R square, is equal to 2A square plus A square, that is see 16R square is equal to 3A square. Then the radius is root 3 by 4 into A. This is the radius of BCC systems is R is equal to root 3 by 4 into A. And then to find out the atomic packing factor for BCC structures, then write down the nearest neighboring distance is 2R is equal to A root 3 by 2, or lattice constant A is equal to 4R by root 3. Number of atoms per unit cell we have already known is 2. Then volume of the single atom is also known, that is 4 by 3 pi r cube. Volume of all the atoms in a unit cell means the number of atoms per unit cell into volume of a single atom, is it right? That is the V is equal to means the volume of all the atoms in a unit cell is equal to 2 into 4 by 3 pi r cube. This 2 represent the number of atoms per unit cell. That means how many atoms to form this BCC unit cell, that is 2. Volume of the unit cell is V is equal to A cube. Put this volume of all the atoms in a unit cell divided by total volume of unit cell denote the APF, that is the atomic packing factors. The number of atoms per unit cell into volume of one atoms divided by volume of a unit cell. This is the formula for atomic packing factors. See, put these all the values in this formula, that is 2 into 4 by 3 pi r cube divided by A cube. Put the value of R. The value of R is root 3 by 4 into A, that is cube. This A cube get cancelled. then A cube get cancelled. Then the remaining values is root 3 by 8 into pi. Put the value of pi, and to find out the resultant value is 0.68 or 68% space will be occupied in this body center cubic structures, or remaining space are empty. See, in BCC structures is closely packed structures, means in a body centered cubic structures the atomic packing factor is 0.68 or 68% space are occupied, and remaining 32% space are empty in a body centered cubic unit cell. So the BCC structures is closely packed structures compared to simple cubic structures. Means this is the closely packed structures as compared to the simple cubic structures. Is it right? This is the atomic packing factor for BCC structures. Next, we have to discuss to find out the atomic packing factors, radius and number of atoms per unit cell for face-centered cubic structures. This is the unit cell for face-centered cubic structures, and this is the front view of these face-centered cubic structures. See, these unit cells to form 8 atoms situated in on 8 corners, and 6 atoms situated on 6 faces of this unit cell. Is it right? See, in this this is the face-centered atoms. Or this is the unit cell, excess unit cells. This is the front view of this FCC unit cell. This is the face-centered atoms. This is the corner atoms, and all the corner atoms touches to these face-centered atoms. And the number of atoms per unit cell, it means how many atoms to form this face-centered unit cell is 4. That means 4 lattice points, or this is the number of atoms per unit cell. using this formula and to find out that is the 4 atoms or 4 lattice points to form a FCC unit cell. Meaning the number of atoms per unit cell is 4 for face-centered cubic structures. Then the coordination number for FCC structures is 12. Is it right? How to find out the coordination number? That is the nearest neighboring atoms or closest atoms. For each plane, there are 3 planes xy, yz or zx. Each plane there is 4 atoms, means 4 plus 4 plus 4, that is the 12. Is it right? That is the coordination number. Then atomic radius is OA divided by 2. See in a figure. In triangle ABC. In triangle ABC, using Pythagoras theorem, and the value of AB is A, BC is also A, because this is the cubic structures, means all the sides are equal, and this AC, this distance is 4r, because this is r, this is 2r, and this is r, means total distance is 4r. Put using Pythagoras theorem for this triangle ABC, that is the AC square is equal to AB square plus BC square. Is it right? C, using Pythagoras theorem, that is AC square, AB square plus BC square. See, put this value, all the values in above equations. Then to solve these equations, that is the r square is equal to 2a square divided by 16, and the value of r is equal to a upon 2 into root 2. This is the radius of this face-centered cubic structures. And then the nearest neighboring distance is 2r, is a root 2 upon 2. Atomic radius is 2a into 4, and the volume of single atoms is 4 by 3 pi r cube. These things already discussed. Put the value of r, that is a upon 2 into root 2. This is the volume of single atoms. Then to find out the volume of all the atoms in a unit cell is number of atoms per unit cell into 4 by 3 pi r cube. This is volume of atoms in a FCC unit cell. Then to find out the atomic packing factors for this unit cell. Atomic packing factor represent the occupied space or unoccupied space. This is the volume of all the atoms in unit cell. 4 represent the number of atoms per unit cell into volume of all single atoms, or 4 by 3 pi r cube. Put the value of r. Is it right? And this is the volume of all the atoms in a unit cell, and this is the volume of unit cell. V is equal to a cube. Put this V and small v and capital V in this formula, that is the volume of all the atoms in unit cell divided by volume of the unit cell. Put this value, then there is the resultant value pi upon 3 root 2. Solve this value, or then there is the 0.74 or 74% space. This is the 74% atomic packing factor for FCC structures. In FCC systems, means this value represents the space occupied by atoms and by an unit cells, and remaining 26% space is empty. Hence, these systems is atoms are closely packed as compared to simple and BCC structures. Means atomic packing factor for FCC structures is very high value, that is 74% space are occupied and only 26% space are empty. That's why these structures are closely packed structures, as compared to simple cubic structures and body center cubic structures. Means the atomic packing factor for the structures is very high. That's why this is the closely packed structures. uh, Thank you. Remaining part we will discuss next video lectures.